Hello everybody, welcome to Scientific Method Review number 2. So just a reminder, you can take notes however way you want, including now using fill-in-the-blank notes from Google Classroom. And if you just want to listen along, that's totally fine as well. So first thing I'd like you to do is to reacquaint yourself with the notes from last week about the saltwater and tomato plant experiment. So read over the variables, maybe read over the hypothesis, and get ready for today. And step number 2 is to read the remaining steps in the scientific method notes. So I'm hoping to go a bit quicker today, and this will allow you to be prepared. Last week we ended off with the hypothesis, and even though I just asked you guys to read over it again, I have it up here because it's going to be important as we build our list of materials. That's actually our next step. So I have tomato plants, I know that for sure. I have 3 different salt water concentrations. I also have growth as my responding variable, so I will need to keep that in mind when I'm thinking what materials am I going to use to measure growth. All right, so materials. I want you to think of materials kind of like a shopping list. What would someone need if they wanted to recreate your experiment? The first thing you always want to make sure is that you have your subject of your experiment and how many. Okay. You then want to make sure that you have clearly identified your manipulated variable, which for us is the concentration of salt water. So what I've done here is I've been really clear with what the concentration is. So our first plant is a control. It's going to have no salts. Okay. The second plant has a very specific concentration of 15 grams of salt in 1 liter of water. And the third plant, again, a very specific concentration, 30 grams of salt in 1 liter of water. And the reason why I've been so specific is, and not just said medium concentration and high concentration, is because I want someone to be able to recreate my experiment with high precision. The next thing is I need to be aware that I am going to have materials that are going to help me measure my responding variable. So here I have a ruler with centimeters and millimeter markings to measure height. And I've also included a camera because that's going to help me take pictures of observations of my qualitative data. So quality, like color of leaves. You can also start controlling your controlled variables by being specific in your materials list. For example, with the 3 tomato plants, I've specified I want them to be the same age and same height at the beginning and to be in the same size of containers. As well, I want them to be in the same environment, the windowsill, to experience the same temperature and amount of sunlight. The procedure. So the procedure is really how you will actually do the experiment, and we're going to have numbered, detailed steps that give us a really good description of what to do. Every step in this procedure is really important. I just want to make a few comments. The first one is to prevent any confusion, you always need to say label the plants. Next is we are going to be really clear what plant gets what concentration of salt. So plant 1 gets this concentration of salt water, plant 2 gets this concentration, and plant 3 gets this concentration. And each plant will be watered with that concentration every day. For observations and results, I wanted to do a quick review of the different types of data we can have. First is qualitative data. So again, anything that has a quality that you describe with words. So for example, the leaves were a yellowy green color. Next, we have quantitative data. That's anything that you can describe with a quantity, with a number. All right, so for example, 3 candies. And please don't forget, we are still going to follow the rule of manipulated variable on the x-axis with a graph, and responding variable is always on the y-axis with a graph. So if you forget, my little handy trick is dry. So responding variables on the y-axis, mix. Okay, the manipulated variable is on the x-axis. Here's an example of a table, and the goal of a table is always just to organize the data that you've collected. And I just want you to note that we always have a title for our table. If you want a more visual way of seeing the data, we always recommend making a graph. So a graph, like you see here, first of all, I've just said title. You can share the same title actually, but you do need to have a title as well here. And the graph is really clearly shows us that plant 1 with no salt added to the water has grown really well over the 2 weeks. Plant 2 with some salt added, so a medium concentration of salt, 15 grams per liter, grew all right, but not as well as when we didn't add any salt at all. And finally, plant number 3 that had the highest concentration of salt added, we see a decrease in height, which we can infer means that the plant has wilted. An analysis is not required for this experiment, so we'll just jump on to conclusion. Any good conclusion has 3 parts. The first one is we're going to say, based on our results, our hypothesis is either supported or disproved. We are then going to use data to back up whether our hypothesis is supported or disproved. And the last thing we're going to do is talk about different sources of error that could have affected our results. If you are taking notes along with me, I encourage you to find 3 different colors. What I'm going to do is I'm going to try to find these 3 important parts of a conclusion in the conclusion example. And I invite you to do the same. So if you would like, you can pause the video and then play it and I'll show the answers. Okay, first of all, I can say that my hypothesis was clearly supported and there's lots of data to help me back that up. The first thing is plant 3 that had the highest concentration of salt water used for watering wilted and started at 10 centimeters and finished at 5.3. So we can really clearly say that there was a negative effect to adding that much salt while we were watering. We can also compare plant 2 that had 15 grams per liter of salt water concentration and plant 1 with no salt concentration added to the water. And the way we're going to compare that is we're going to say plant 2 with some salt added had 14 centimeters and plant 1 with no salt added had 24. So when we compare these 2 values, we can say that if we don't add any salt, it grows 10 centimeters more than even if we add a little bit. So even adding a little bit can have a really negative really negative effect on growth. Then finally, we're going to look at source of error. We've identified a source of error in our data. So we saw that our plant was growing really steadily and all of a sudden it didn't have much difference in growth. So it went from 21 centimeters on day 10 to only a tiny increase on day 12. Now what we're going to do is we're then going to try to explain. We're going to say this source of error could be due to maybe we made a mistake in watering, or maybe that plant just used its energy to produce more leaves instead of getting taller. And so, in conclusion, see what I did there? We can find all 3 important elements of a conclusion, and this is an exemplary conclusion. Last but not least is the future research section, and the goal of this section is really just to wrap up your scientific experiment. So one thing you'll talk about is in what way could you use the information you discovered to improve society? So how does your information make a difference? And you'll also look ahead and say, what is your next experiment? So the example included in your notes is a really good example, and I encourage you to use it if you decide to do future research for our assignment. So in the next video, I'll briefly explain the assignment. This is something that I'll be able to give feedback on, and it's a really great way to practice the scientific method. Thank you guys so much for listening. Have an awesome day.